So thank you. Good afternoon. As Matthias said, yeah, I started it with Intel when the 286 was the latest and greatest processor. And at that point in time, everybody used to say to me, well, hey, why do I need the 286? I'm happy with the 8088 that's in the old IBM PC. Why do we need the 286? And it's far too much performance. Intel, for a long time, has been telling people, you can never get enough performance. I think it's been shown over the years. If you think back in times then, 286 was probably, 16 megahertz? As a processor, single core. Latest generation CPUs today, over 3 gigahertz, multiple cores, and massive changes in the microarchitecture. We have significant increase in performance over the years, and we still don't have enough. If you talk to the software guys, talk to SAP, they always want more and more performance. So I think there's one thing about this industry going forward is, you can be in it for a long, long time, but you know that in 10 years' time, 5 years' time, things will change again. So what I want to do today is I'll talk a little bit about data center and client. We've heard a lot this morning about cloud computing, right? And you listen to the industry pundits today, and everyone's saying the world is moving into the cloud. I think one of the biggest challenges for IT organizations is actually making that transition. Right? It's not a cloud or nothing type position. You've got to take your existing infrastructure, you've got to evolve that, you've got to plan the transition into the cloud. And whilst doing that, you've still got to maintain and make your existing infrastructure more efficient. You can't say suddenly drop everything you've got and move out to Microsoft. Much as Microsoft would like us to do that, in reality, that's not the way things are going to go. Or that's not the way that we believe things are going to go. So what I'm going to talk a little bit about is some of the nearer term things, right? Some of the things you can do inside the data center itself. And also, one topic that hasn't been raised here today, we're going to talk a bit about the client. Right? Clients consume power. Clients are an impact on our energy consumption inside the data center. And I'm going to talk a little bit about some of the things we can actually do to make them more energy efficient. So we look at an IT organization as a holistic whole, not just about the data center itself. So IT sustainability, it's about understanding what you've got and effectively using the resources that you have and taking benefit of transitions as they take place. Right? So effectively, at the end of the day, you can consume fewer resources. Actually, consuming fewer resources may or may not be the right thing to do, because if your business is continuing to expand, maybe it's a case of using your resources more efficiently. You may not consciously want to reduce the resources you've got, but to use what you have and get more capacity or more throughput from those resources. So it's about actually understanding what you've got and making more use of it. And much like Samsung, or much like Samsung Semiconductor, Intel's core business is manufacturing silicon. Right? We are a silicon manufacturing company at the end of the day. We have a model that we call the tick-tock model in the way we design and architect our silicon. For one generation of the process, we evolved silicon. We changed the silicon node. So we moved from 90 nanometer to 65 to 45 to 32 and on to 22 in the future. And we're doing that on a cyclical basis. Every 2 years, we evolve the silicon process. On the alternate years, we evolved a microarchitecture. What that means is we take the same piece of silicon, the same silicon technology, and we change the way we design the processor. It doesn't impact what the processor does in terms of executing the instruction set, but by computer architecture, we can change and make more efficient the processor itself and the way it executes the instructions. So every year, we're cycling through our processor. We're actually improving the overall efficiency of the underlying platform, both in terms of the data center and in terms of the client. All right. So, small transistors are quite good from our perspective. We can get more on a piece of silicon, right? More on a weight, more on a die. The interesting thing is what you do with those transistors. It's not just a case of making the thing go faster. It's actually how you can improve the technologies that you put onto the wafer itself and onto the die, so that we can actually do more sophisticated things. We can become more efficient, and we can execute more instructions, more workload within the same piece of silicon. The other factor we get from reducing silicon size or transistor size is it takes less power to switch a transistor. Net result is, through successive generations, we consume less power with our devices. Or that's one vector we can run in. Right, the other vector, of course, we had this discussion this morning about should there be a label for energy efficiency on servers or on devices? Maybe there should, but the problem with anything like that is energy efficiency is only one vector. Right? It's great saying I've got to have Class A energy efficient devices if they don't deliver the workload that you need. Right? You've also got to look at the workload that you've got to get delivered from that device. And at times for people it may be a case of say, okay, I want to compromise. I don't necessarily want to take the lowest energy consumption device, but I want a device that gives me the best workload or best throughput capacity. And so you need to look at both vectors in terms of doing this. So, we get more capacity, we get smaller die size, we get lower energy consumption through successive generations. And we're doing that on a, you may hate us for it, right? And a lot of IT organizations say you change things too fast, but, we're running on a thing called Moore's Law, which everybody's probably heard of. Every 2 years, the capacity we can put onto a single piece of silicon doubles. Right? That's just one of the fundamental pieces of science within our industry. And that's, so we continue to drive that forward. And the other thing you need to think about when you look at your IT infrastructure, you can only manage what you can measure. Again, a lot of discussion about PUE and getting down to a given PUE value. I think the real interesting factor is, okay, so if I get there, how do I manage it? Right? How do I control it? Right? It's one thing measuring it and knowing what it is. The other thing is proactively being able to tune that down. What do I do to improve my PUE factor inside my existing infrastructure? So when you look at the footprint of any infrastructure today, obviously the data center is pretty large in terms of the impact. There are other areas as well. There's outside the data center, there's the client devices. Both impact your CO2 footprint. Within inside the data center, servers obviously contribute a reasonable amount of the energy consumption. But it's not the only device. Networks consume power. We need to think about what we do with our network infrastructure. How can we improve the energy efficiency of the network? And also, there's this brown spinning stuff we've all got out there called storage. Right? What technologies and what can we leverage to improve the storage's power consumption? Right? It may not be doing a lot, it may not be idle most of the time if we're not actively accessing it, but it's still consuming power. So we need to look at all this picture and look at how over time we can improve the footprint of the platform, or the footprint of the data center, footprint of our infrastructure. The one element of all of this is, that we found is, you need to be proactive about this. One thing we've seen with a lot of companies taking a proactive approach to server refresh, and we'll talk a bit more about why in a minute, can lead to significant savings inside the infrastructure. The other thing we need to think about is, IT is not just about data centers for most organizations. You've got a bigger estate to manage. Right? You do have the client estate, you do have the networks, we do have monitors out there. Right? There's lots of other things that are consuming power that when you look at an industry or from a business, from a holistic perspective for an IT organization, we need to look at everything there, not just about the back end. So, having said that, if we just look at the back end itself and what we can do in terms of sustainable data centers and changes that we can make, beyond taking the massive leap of faith and moving into the cloud, right? But how we can actually evolve existing infrastructure in our preparation and our transition into cloud computing. When we look at data centers, and when, they're made up of CPUs, that's the core of the business, it's what generates the instructions, it handles the workload. Server sat around the edge of it, memory, storage, etc. And then you've got all the infrastructure sat with that. Things you do up at the CPU area can affect the efficiency of the data center. Right? It's great going to low-power CPUs, but one of the fundamental laws of science says, if I make my CPU consume less power, it generates less instructions per second. Now, it's kind of the way some of the physics work. So we need to understand the efficiency up there. What is our requirement of any given individual device? Right? Sometimes it is appropriate and suitable to have lower performance devices. Other times, if you want to run your SAP workload, trying to do that on a low performance device may not be the most sensible thing to do. You may well want to keep a reasonable amount of performance inside your infrastructure to handle that workload. We can't turn around business intelligence analysis inside seconds. You can do a lot in memory, but hey, you've got a lot of instruction cycles to process at the same time. As you move out to the data center, stuff out there, things you do out there materially impact the power consumption. Right? So it's a case of understanding what you've got there. So we said, changing servers, just right down at the base level, think, proactive refresh. As we go through success, we've already seen we're making successive generations of silicon and changes in silicon geometry. As we do that, that encourages the vendors that make servers to change the platforms. And we put new technologies and new capabilities into the silicon. They evolve the whole platform. So as you go through successive generations of server platforms, they become more sophisticated in terms of power management. When we look at, take an example here, a lot of stuff out there today is probably deployed in the 2005 timeframe. Now, if you think of your life cycle inside your server, everyone was forced to change effectively back for the Y2K, the year 2000 transition. Now, 5 years later, we saw a lot of people transition, refresh the servers at that point in time when the first dual-core platforms came into the marketplace. So in the 2005 timeframe, if you look at, and that's a fair amount of stuff is out there, is still installed today and running today. When we look at out there today, we look at what the impact would be of changing that and refreshing that with the latest generation platforms. Right? We can get something like a 15-to-1 consolidation ratio. So that's we've increased the performance of the server 15 times over a 5-year period. So you could take out 15 racks and replace it with one rack, or 15 servers and replace it with one server. It depends on your scale of your business. The net result there, you're getting 15-to-1, you're getting about a 95% reduction in energy consumption within the server platforms. This is significant. You've not decreased the workload your data center will be capable of handling. Right? Reality is we suspect people will actually go in the mid-ground between the two, and increase their capacity at the same time as replacing the servers. So you won't necessarily do 15-to-1, maybe you do 10-to-1, 5-to-1, something like that. Normally, you want to, over time, the demands on your data center have increased. We see very few customers that say, hey, I'm happy with the same capacity in my data center as I had 5 years ago today. Most people want to get some benefit from the latest platforms. So you can make significant savings just by consciously looking at what you've got and refreshing the infrastructure. And you start to do the sums, and it's a fairly simple spreadsheet calculation. If you get stuck, we've got some tools up on Intel.com that can help this to get the payback numbers. What's the CapEx cost plus the OpEx cost of the new servers versus the OpEx cost of operating the old servers. And you can do you may say, okay, my numbers are slightly different, but you can do the sums. You can calculate when you'll get payback on this. And for most businesses, we reckon you'll get payback well within inside the year. You'll actually be saving money. And saving money can then equate to being more green, if you look at it from that perspective. But you're saving, because essentially you're saving power. And this equation works no matter what you do it with. You need older servers, newer servers. Depends on what you're replacing. It works on the basis, we're delivering more capacity into latest generation platforms than previous generation. The other factor of doing this is that the latest generation platforms have much, much more sophisticated power management. You look at what was deployed back in 2005. Most of those servers, if I asked around the room and said, who power manages their servers inside their data centers, I doubt I'd get many hands put up. Right? The latest generation servers all come with very sophisticated power management. Right? They can shut themselves down, they can idle. We also work on a hurry up, get idle type process. Right? You get stuff done quickly and idle faster if necessary. It works in the client space, it works in the server space. But the principle is that we're working on now is how do we better power manage the platform? Even to the extent that the latest technologies inside the servers allow us to set power policies for servers. Right? Now, it's one thing understanding power consumption, it's another thing actually being able to manage it. Right? And can I determine that the consumption of my server will be X based on the time period? Overnight, when I'm running on lower cost power maybe, I want to run my servers faster and process my workload quicker. During the day or during peak hours when my power is expensive, I might want to slow down my servers and consume less power. The other interesting factor is, if I have a power excursion and I have to run on batteries, if I can slow my servers down and consume lower power, I can extend my battery life. So there's lots of technologies that are coming into the servers that can help extend and improve the energy efficiency of your data centers. But it goes beyond the server. Right? It's not just about the physical processor and what we're doing there. There's lots of good stuff. It's virtualization, it's silicon technology, it's power technology. No, they have impact. It's about the network. as well. Right? What happens when we optimize the network, when we move to a unified networking environment? Today, most servers have got network pipes coming off the back, typically 1 gig, and they've got fiber channel out to the storage devices in most large data centers. Now, when you move to a unified network environment, you put everything down across a consistent Ethernet network, you start to strip out some of the other technology, some of those other devices that are there. Right? So this, again, can lead to significant savings. And especially as you increase virtualization inside your data center, you need to increase the network throughput. We need to move as an industry to at minimum to 10 gig in the near term, and then as the networking industry evolves, we need to embrace faster and faster networking so we don't get constrained by bandwidth. The other element is the storage devices. Increasingly, we're seeing servers and devices coming out with SSDs installed. Right? The interesting challenge going forward is actually how the software optimizes itself to use the SSDs. SSDs are not as big as traditional storage, but they have other properties. They're faster, lower. Their latency is shorter. Right? Their read-write times are better. So the question is then, how does the operating system and how does the database software optimize its usage of the storage devices, and hence lower the overall power consumption of the platform? So there's significant things to think about inside the data center itself, even without this jump into the cloud, right? And how you can evolve and change what you've got. Our own IT organization, Intel makes chips, but we have a substantial IT organization just to manage our business and to develop our silicon. We've published a number of white papers. If you've not looked at any, it's worth going onto the Intel.com and looking at some of the stuff our IT group publish. They publish a lot of their best-known methods as white papers. And they reckon they're going to save about $250 million over an 8-year period by proactively refreshing and evaluating what they've got inside their data centers. And that's not to be sneered at, and that's without moving into the cloud. Yes, we have cloud infrastructure internally. We use external cloud sources, right? But this is just straight management of the data center and proactive management of the data center. So changing gears a bit, the other element you've got within the estate, right? And the one thing I think we tend to forget a lot of the time is the client devices. Right? We focus at the back end because it's the hot spot. It's the one thing that everybody sees. The issue with the client devices, they're distributed. They're on everybody's desk. You can't say what the power consumption is of all your client devices, but they do contribute to the overall energy consumption of the business. So, look, there's a number of things we can do here in terms of client devices, again, to optimize their power, be they desktop or notebook. Right? Power supplies, we can specify highly efficient power supplies from the vendors. Power supplies in client devices didn't used to be that good. We lost a reasonable amount of power across the power supply itself. 80-plus power supplies should be the minimum nowadays. Hard drives, move them over to SSDs. Memory, obviously, Samsung are talking a lot about what they're doing in memory technologies and increasing the energy performance of the memory technologies. And there's also, in the client device, let's not forget the CPUs there as well. Successive generations of the CPUs consume less power, deliver more performance and more capability. As we integrate graphics into the CPUs, again, we're removing yet another point of power dissipation inside the device. So we need to think about this and, again, consider ongoing replacement and refresh of the platforms. Now, when we look at what the impact of that is, we did some calculations here, go back in time at the energy consumption here of a traditional desktop versus, and that was an unmanaged desktop, right? Versus migration through a succession of managed desktops through to client mobile devices. Right? As we go mobile and as we increase the management of the client devices, we can get better control of their energy consumption and we can lower their energy consumption. We can proactively turn off devices that are installed inside our office buildings through management. With mobile devices, again, the device comes off the network, it shuts down, you get more control over it. Right? So this is, as we go forward, we can use less energy, and we can get it through proactive management and control of the estate. If you look at what that relates to, if you really want to turn this back out into tons of CO2 emissions, right? You get natural energy savings, and you can then translate that through the calculations into your the savings of CO2 for your CSR reports. So you can work this stuff out. basic message here is, don't leave old stuff installed. Right? It is not, saving money by not replacing is not actually saving the business money in the long run. Proactive refresh actually spend money, net comes in with a net result in saving or net savings. So, in the client space, we're saying, look, proactively replace the older stuff, take it out of operation. The later generation devices are more proactively power managed, they're more energy efficient. Look at using SSDs. Right? If nothing else, they break less frequently than the brown spinning stuff. If someone drops a notebook with an SSD in it, you're not going to crash the disk. Right? I did that to mine the other day. Damaged the chassis, but I didn't damage the disk. Right? We've used SSDs. Employ remote client management. Look at using vPro. vPro technology allows you to proactively manage the client devices, even when they're not powered on. Right? So you can force devices to power down. You can manage devices, do updates, etc., when the users are not present. And then, put power schemes across the devices. Don't just sit there and think, oh, the users will turn them off. Force power policies onto devices. Think about it, take a proactive approach against this. So, in summary, there's a good business case for doing this. There are lots of good arguments why we should all move to the cloud. But in the interim, before we all get there, right? And I don't debate. The world is. Parts of the world will transition towards cloud computing. Other parts of the world will say, nope, I want to stay where I am. I like control of my infrastructure, or for other good reasons, they want to keep that infrastructure going. So look at what you're doing. Take a baseline, measure it. Only once you understand what you've got, understand your PUE value, can you then manage that PUE value or manage your costs. And one of the good things about PUE is great. It's a point in time. The other thing, PUE is a point in time. PUE varies dramatically depending on conditions. Right? And also, the other thing is, as you change things inside a data center, you need to understand what the impact of your PUE is. Because you measure it once and you've got it. But then if I change the networking, I reduce the power consumption somewhere, without changing other elements, that can actually put your PUE up, not down. Right? You need to look at this stuff. And also the other thing is monitoring, get ahead of regulation. Somewhere down the line, the folks in Brussels are going to get wind of, and want to start putting more control over what we're doing. So look at this stuff, understand what you're doing, so that as they get more sensitive to this, we're actually in a good position to continue to drive the business forward, rather than letting regulation sustain and control what we're trying to do. So that's what I had. Thank you very much. Hopefully that was useful. I think we've got your opportunity now, or later some questions on the panel discussion to, I'm sure we'll come up with some good ones.